morning, students. In this video, I will show you the demo of your laboratory class, how to use the EDA tools Xilinx design flow. So hope that everyone have installed the Xilinx model sim simulator in your laptop. So if you open that Xilinx, there are 4 windows. This is a coding window. This is your sources window. This is your process window. This is your console window. In this coding window, you can write .v file, .v coding, HDL coding, and what are the files you created, which will display here in the source window. Then you can choose the files, and you can process the synthesis flow and simulation flow. You can do by selecting the each and every. Okay, you can check the syntax. You can create a schematic. If you see here now, you can create a schematic. You can check the syntax and implementation, floor planning, placement, routing, and the file generation. Everything you can do. All are automated. EDA tools all are automated. So the synthesis process you can do, and you can get the timing report, area report, cell count, areas, timing, and speed. Everything you can calculate. It will be displayed. The report will be generated automatically. Okay, now I'll give you a small demo how to create a file. For example, so already one of the file I have generated. So I'll explain in this circuit the full adder. We'll design a full adder circuit. Okay, the coding styles, everything I will teach you in theory class. So with that, the background knowledge of the digital circuits, you can simulate any one of the any circuits. Okay, further the first step, create a in a desktop. Don't create a folder in C drive. Please you create a folder in D drive with your register number. Okay, so create a folder in D or E drive with your name and register number. Okay, that library, the path should be important. After creation of the folder, you open the file, create new project. Then see, I created my folder with my name and register number and in the D drive. You give project name. The project name I'm going to create full adder. Okay, full adder. So the language, every window, you just drop down menus there. Drop down menu, you drop down, and what are the things available, you learn. So normally in this window, see, this is a menu bar. File, save, then view, project, source. So I told you, this is a source window. This is a process window. You can click on that, and you can. Sometimes, ma'am, it is not displayed here. Na? You check the source window, process window is selected or not. Then simulation. Okay. Then once if you if you are in a correct path and with the project name and next level, you select next level. So in this screen, if you see the device details, what is the device? The device family. If you see the device family, there are different devices. Spartan, okay, Vertex. So what are the devices supported by Xilinx will be displayed here with respect to different applications. You can select. So Spartan 3 I selected. So the Spartan 3 device family, the device is given 3. Okay, then package type, all the details you can see here. So the simulator, see the simulator, model sim simulator. It supports model sim simulator. And the language, you can drop down here, VHL or Verilog. You can select Verilog. Okay, and next, then create a file. We are going to create a file. So new source, select new source. In the new source, you give a file name. I am going to design a file name full adder. Full adder, for example, in a short name full adder FA underscore. So the file name, you are only giving your file name, your own name, but it should be a understanding format. So it should be understandable. So for example, there are different modelings I taught. It may be a gate level modeling, or behavioral modeling, or data flow modeling, or structural modeling, or switch level modeling. So in order to understanding purpose, you can give a name. For example, now I'm going to design the full adder using data flow modeling, for example. So for understanding purpose, the file name I'm given here df. So a full adder and df. So the file name, better the file name and module name inside the coding, the module name, okay, and the file name. If you give the same, you can avoid the confusion. Sometimes the students are used to give different file name, different module name. While mapping into the structural design, the name will be confused. What name you given? Sometimes the students will give the file name. Only you have to, when you instantiate some of the programs, that time you have to give only module name. Okay, so that what I am suggesting, better use same name for file name and module name. Okay, so my location D drive and my file name data flow modeling I'm going to do. Here you have to select the Verilog module. Okay, then next. So in this Verilog source model name, what I name created model name FADF model name. My model name also same. We can change, but model name and file name better it should be same. So whatever the name you're giving here, that will be displayed in coding also. So better file name and model name, better you keep same. So here you can define the ports, for example, full adder, summon, sum you can give yes. Here you can define sum is output. Then what are the MSB, LSB, 4 bit or 2 bit or 3 bit single bit you can choose. Then carry. So that is also output. It may be output or input. Then A, always specify the output first, followed by inputs. A as input and B as input, and one more full adder C in the names. Okay, while using the port names, you should not use any keywords of your Verilog HDL. So output. So you can create next. Okay, either you can do like this, otherwise no need to. Okay, otherwise no need to give anything. Simply you can go to the next level. The model will be created where you can define all the ports, input ports and the output ports. So better, my suggestion, don't specify anything here. You go to the programming window directly and there you can specify the terminal list, IO port list. Okay, so I cancel this one. So new source. So what is the name I given? FA underscore DF and Verilog module. Next, then next, then in this window, see what are the informations they given. Your source name and model name both are same. What is the source name? FADF.v file. And what is the model name? FADF. Okay, Verilog model. Then you finish. Okay, then so here source file FADF.v Verilog model. So next you give next. Every window when it is open, give some pass and go through what is the description is given. Then next, then here the source file, if you want to add in a, for example, if you are going to design a 4-bit full adder, in that you are, if you are going to use a single bit adder, that time you can give a add source, create a model name 4-bit adder, then add the single bit adder source file. Now we are getting only full adder. So next, so see again this window, just go to, simply don't do everything. See this window, what it displays: project name, full adder, the location and device names, and what is the file, source file. The source file is fadf.v file. Then finish. Do you want to save the changes you made to HADF? HADF I don't want, so no, it is full adder. Okay, so now see, I have created. So now if you look at the window for Windows, so the source, what the source I created, full adder source file I created, .v file is there. Okay, then if you select the .v file, so all the process window will be, see if I select here, simply if I select here, no, nothing is here. So by selecting the .v file, select the .v file, confirm that whether you have opened the .v file, full adder file, then in the process window you can see all the processing steps. Okay, then right click, then we are not adding any source now. So once if you selected, this file coding window will be open. So this is the coding window. Okay, full adder. In the coding window now, the double slash is a command line. Okay, where you can fill your own personal data. For example, I am belong to SRMIST faculty and I am working as an assistant professor. Senior selection grade S.G selection grade. My ID is 100265. Some data. Oh, okay. Engineer name Alarmati. Okay. Assistant professor SG employee ID. Engineering faculty name. Otherwise, here I know faculty. No faculty. So you can give student register number, ID, everything. So the date created, the design name. The design name I'm going to design full adder. Full adder using data flow modeling. Full adder using data flow modeling. Okay. Design of combination circuits I can give. Some understanding purpose. Combination circuits. Okay. Target device here I'm going to do Spartan 3E for example. Tool versions I'm using Xilinx model sim. I think version 7. You can download the latest version which occupies more TB. So once if you are familiar with the design flow, then you can switch out to the Synapses or Cadence or any other tools, EDA tools. Then these are all not required. Dependencies revision. The line you can additional comments I remove here. So date and the title of the program. Full using data flow modeling. Okay. So this is all I can remove. So now the coding window is open. So this is the keyword module. Okay. Full adder model name. We have created no model name. What is the so name we given the same name. Open the bracket. Specify the output first. Sum comma carry. Okay, dear. And followed by the inputs A comma B comma C in. It's a full adder, no? So model name. Open the bracket. Sum carry A B C in. End with the semicolon. So what is that? Each and every line at the beginning, you should have a practice of giving the commands for each module. Then you will get a clear understanding. Whenever you open the file, what you have done, you can understand. So here, this is the declare the specify the port list, black box. The black box. What are the I/O ports are there? Specify the ports. Okay, specify the ports, whether all input ports, all output ports. Only specify the I/O ports, not wires. I/O ports. Okay, I/O ports of your black box design, because the black box, inside the black box the circuit will be there, but in the main module this is a top level module. is a top level model. How to define top level model? Top level model. So in the top level model is a black box. In the black box, what are the input ports, IO ports available? So black box, you think it is a chip. Inside the chip, whatever, let it be. That coding will write it later. But outside, only the IO terminals, IO ports, input ports and output ports. Not internal connections, wires, details, everything. Only black box details, input ports and output ports. You have to define. So as per our full adder, the black box, the three inputs A, B, C in and the two outputs S and C. Specify the output first, followed by inputs. Because why am even if you specify input first and output second, it will work. It will simulate. But when you create your own libraries, okay, own primitives and all, so the libraries are developed by using output followed by inputs. So better use output followed by inputs. The next step, so end with a semicolon. The next step, declaration of the ports. What are the IO ports you have specified here? So it belongs to input or output you have to specify. That is a declaration of the port. So the declaration of the ports is the output or input you have to specify. So by using the keywords output and input, output is a keyword. Output is a keyword. So what are the outputs here? Is a scalar, single bit full adder. This is a single bit full adder. Designer full adder, single bit full adder using data flow modeling. So output. So output, what are the scalar only? Only one input, one output. So it is not vector declaration. So future, how to declare the, when you go for the 4-bit n-bit adders, I'll tell you how to declare the n-bit. Okay, so for that you have to completely thorough with the Verilog constructs, Verilog HDL, data types, how to define the ports, port mapping rules, how to instantiate the modules. So in that HDL language, you will study the complete different modeling, different the data types and the keywords, identifiers. Okay, how to write the coding, that and all we'll study in detail. Now the simple program in the how to simulate by using the Xilinx design flow. For that only I'm giving instruction here. So output here, what is the output? S and C, S comma C is the output. So every statement end with a semicolon. Semicolon, not semicolon. You do some mistakes, no problem. Colon, semicolon. You just instead of semicolon, you put the colon. It will display the errors. Okay, let it be. We'll check. Here I actually end with a semicolon. Here I'm giving colon. We'll while running time, we'll check whether the errors are showing or not. So once the errors are showing, it will display in the console window. In this window, what are the errors? Similarly, in this there's a tool which will display only the this is syntax in this is a coding syntax like C language, keyword, open the bracket, in the semicolon. So if any mistake in the syntax error, if you do any mistake, it will show the syntax error here. I mean, keep in mind that it will show only syntax error, not logical error. So what is the difference between syntax error and logical error? Logically, if you are doing instead of sum is equal to A XOR P XOR Cn, if you write some other equation, no, A and B C XOR. So if you do that, if you type that wrongly, then you will not get the proper output. So that is a logical error. Logical error done by you only. So you have to fundamentally you have to be very strong in what is full adder, what is a full adder truth table, what is the full adder boolean expression, then how they are implemented by using gates, and the black box, how you are defining the inputs and outputs. So that concept's a fundamental concept, you have to be very thorough. Otherwise, simply opening the tool, the creation of files, then do this simulation with some others coding file you should not run. You create your own coding file .v file, design properly, you design and use any one of the modelings, data flow modeling or gate level modeling or behavioral modeling. Okay, then you simulate. So if you do any mistakes, debug your program, then simulate and do. Okay, so debugging is very important. Output, the next line. So what is the command I can give here for understanding purpose? So the command may be double slash for single line comment, or stars slash star for multiple line comment. So declaration of ports, declaration of here output ports, declaration of output ports. See here the output is a keyword, but here is a command. It will not compile. Commands line. Declaration of output ports. Okay, you can go for the multiple commands, multiple output ports. So here uh, uh, yes and C are the outputs. For understanding purpose, I'm writing. Okay. So S and C are the outputs. You can end with the star slash. So here, what is my motivation? You should know the commands line, which should not be compiled by the tool for only understanding purpose. So double slash for single line command, and star slash and the end with the star slash is a multiple line commands only for understanding purpose. Okay. Okay. Now, uh, sorry. Next line, input. So output declaration over. No input keyword. Input. So what are the inputs here? Input is equal to A comma B comma C in. A comma B comma C in. Okay. End with the semicolon again. So sorry, here colon I given. Okay, we'll see whether it shows error or not. Okay, but what is the syntax? Logically I'm doing correct. Okay, what is the syntax I'm showing? Here semicolon. Every statement end with a semicolon like C, but in this statement I put colon. We'll check whether error is showing or not. Okay, next one. So model specify the ports. Second one, declaration of the ports. Here declaration of input ports, understanding purpose, double slash declaration of input ports. Okay, dear. Next line. So since it is a small program, okay, we are writing by using data flow modeling. Later, gate level modeling and structural modeling. If there is inside the chip, all are connected via wires. Inside the chip, all are connected via wires gate level. So that wires and all, if you specify the names of for wires, that wires you can display. Wires you have to specify here before starting of the body of the program. This is a module name, out in out output input declarations, and if there is any wires you can specify here. Now in this we are not because since it's a data flow modeling, wire is not required. Only gate level modeling, structural modeling, wire is required. In the data flow modeling, no, there is no wire. Okay, so in the data flow modeling we are going to write the code body of the program by using only primitive cells or operators using the keyword assign. Okay, so understand. So I'll give a description about the data flow modeling. So this is the body of the program. We are going to define a body of the program by using data flow modeling. The data flow modeling using the important keyword is using. So now I'm going to write specify here. Here I can write directly using the keyword assign. Assign is a keyword. Assign is a keyword which is used for, which indicates your coding you return by using data flow modeling. Okay, assign. What is the output? S. S is equal to A. Okay, A. The primitive cells you can use A XOR B XOR C in the three inputs. You know the because this one you should have a complete fundamental knowledge about the digital circuit. Half full adder, sum is equal to the Boolean expression from the truth table. The Boolean expression S is equal to A XOR B XOR C. Okay, so end with the semicolon. So here one more clarification. Either you can the data flow modeling either you can use by using primitive cells. using primitive cells. Here, what do you mean by primitive cells? So, as I said, how do you compare C language? This is hardware descriptive language. So, hardware descriptive language designed for in order to design a digital hardware circuit. Okay, but in here, why hardware design circuit required HDL? What is the special? Why HDL? Because the hardware circuit need timing and parallel concurrency. Because of timing and concurrency, HDL, why HDL is required during the placement industry? Because for all the experiments, first, if you are very thorough with the Verilog HDL coding, the industry people, the three stages of recruiting stages. Okay, first stage itself, they won't ask you, do you know what are the tools? Do you know the tools? So the tools, I know the tools. So that is the tool design flow that is not sufficient for industry. Okay, the industry, the first round, whether you are very strong in the basic fundamental. So as I said, the knowledge, what is full adder? What is the truth table of full adder? For any full adder means already available in the textbooks. So you started to learn only from the fundamentals what is available. There is a baby. Okay. But when you once if you complete the course, you can able to do some mini projects with a higher level of thinking for any applications. So in that case, for your application, after completion of this circuit, I'll give an exercise to you. So this video, this is sufficient to break your mind and what are the application needed for the industry. For example, I'll ask you to design car security system. Okay, you are parking your car in a slot, whether the car is opened by you or the owner or the thief. If you open by you, no problem. If it is opened by any thief, you should hear the buzzer sound. This is a car security system. How you are going to embed this into your car? So you are all crazy with the car. So with so many specifications. So all mechanisms, okay, embedded with your microprocessor and VLSI. So lot of opportunities are waiting in industry, but they will recruit only those who are strong in fundamentals. Not only with the tools. Tools are what other tools are industry tools are available? How to explore the tools in order to get your chip tape out. Okay, so if you chip tape out design flow, do you know or not? All are added advantage of getting job. Okay, but that is not sufficient. The first stage, fundamental round. So last time also, when the placement team comes, when the industry people comes, the first round of selection is only background. If unless you know the basic concept of half adder, full adder, flip flop, important as a core student, core domain. If you don't know the D latch principle, the flip flop principle, so you have completed the course prerequisite do last semester, that which helps a vital role to design any combinational sequencer circuit by using the HDL language, Verilog HDL language. Okay, so first filtering is with respect to your knowledge. So whether you know flip flop and half adder or not. Second round. So this is a demo. Simply I can show the demo. But what is the importance of this demo? So parallelly I'm giving. So the classroom teaching, the classroom hours is not sufficient. Okay, so that the our institution insisted the faculty members go for some video lectures which helps the students to learn at any time and from at any place, and they can explore. So kindly do for students. With that in mind, with out of my experience, so I have started to record the video lectures apart from my schedule. So I'm posting for you. Please kindly go through and explore. So first round is knowledge. Second round, for this digital circuit, how you are designing a chip. For that chip, hardware design, HDL, for in order to design a hardware, the IEEE standard developed, okay, Verilog HDL. So you have to explore the language with the data types, the keywords, constructs, and what are the primitive cells available. Because in C language, do you remember what is the purpose of including sddIO.h? What is the purpose of include math.io.h? Okay, so what do you mean by that? stdio.h dot h header file. So math.io.h means what? Whatever the mathematical functions such as sine, cos, if you want to include, okay, that file you have to include, the library file you have to include to run your program. Without including in the C language code, the first two lines including all the header files required for your program. For example, the C language, printf, scanf, all the statements available in the header file. The input output statements, scanf is the input statement, printf is the output statement. So those are available in the header file. So for that you have to include stdio.h. If you want to use mathematical functions, then you have to include math.io.h. So this is in C language. In C language, the programs, it will run sequentially one by one. Okay, dear, sequentially it will run one by one. Recruiters will come, the competitors, CSC student sitting here. With the CSC student, you are EC students, core domain student. You are sitting here. But the IT people will recruit both CSC student as well as the EC student if you are very strong in logical thinking, logical reasoning. Okay, the learning the tools is different. But how the C students, so the C students, they are studying C. So they will ask the questions. What is C? C? C is a C. You cannot say I know C. You cannot say I know C. How you can say C, S-E-E, C, the ABC alphabet C is a C, S-E-A. C is a C. How much you learn from that? I know beach. So someone will go to beach and touch the waters. Someone will go up to some 100 meters, 200 meters. Someone will go in depth and it will take pearls from the sea. Similarly, you learn some languages, C or HDL, and everyone, by studying the language properly, all identifies all data types, keywords, all data flow modelings, pointers, arrays, structures, unions here in HDL. In HDL, what is a HDL? Why HDL? What are the types of HDL? What is the difference between C and HDL? And what are the language constructs? What are the different operators? Unary operators, binary operators, ternary operators, different data types, different modeling styles, behavioral modeling, data flow modeling, gate level modeling, structural modeling, switch level modeling. Okay, so in depth, but how we're taking pearls from the sea like that, you have to learn the languages in depth. Then that is the upskilling. Knowledge, you are acquiring the knowledge by studying the fundamentals. and upskilling your knowledge by learning the what are the languages are there for designing a hardware design, because the hardware design requires timing and concurrency. Because without what is the need of timing without clock without clock, you cannot achieve the synchronization. Because the clock, you just think of that any bus stop, 8:20 this bus will come, 7:35. So if the time is not specified, the traffic jam. So in similarly the concept inside without clock, all the circuits, there is no synchronization. So in this semester you will study microprocessor and VLSI. Microprocessor and VLSI is a husband wife only. So you have to be as third years as a professional. You have to be you explore both microprocessor knowledge and VLSI. Okay, you definitely will get placement in the core domain. So microprocessor and VLSI. So now our government promoted the India Semiconductor Mission, and so many foundries, fabs they developed in Assam. One fab is there. Why they have chosen Assam? Because of water resource management. Because of water resource management. Okay, they have chosen because you need a more cooling for the chip. So cooling methodology. So what are the all IC fabrication steps? Thousands of steps will be repeated before taking the tape out. Starting from substrate, envelope, diffusion, assembly to layer, photoresist, lithography, ion implantation, making metal contacts, trillions of billions of gates inside the IC. For that, the cooling system, the water source management are very much important. So one of the reason they have started the fab in Assam. But decades, three decades before, the foundry in Chandigarh, Semiconductor India Limited (SCIL). When I have completed my MTech, my batchmates got offer in SCIL. That time they have taken some tape out with 1 micron technology. But now the technology is 2 nanometer, 2 nanometer technology. Okay. So now proud to say that our SRM got the technology files from SCIL 180 nanometer PDK technology file. So the students can explore with that technology file, and you can submit your design to the SCIL foundry. The backend process they will do, and they will give tape out for you. Okay, so if you do some mini projects with the good concepts for some applications, you can go do the RTL to GDS flow by using these tools, either Xilinx or Synapsys or Cadence or open sources, EDA Playground, open source, open road. So either proprietary tools or open source tools you can use, and you can submit your design without fabless. So the design engineers at one place, you can make a design, you can make a chip. The concept of fabless engineers, fabless, no need of fab for you. Design RTL to GDS2 flow. Submit your design to the foundry. Foundry means fab. They will take the tape out for you. So that much facilities now we are having at SRM. Okay. So globally, you can submit your design to our India, SCAL or Taiwan, MOSIS, MOSIS, MOSIS. There also foundry. There also we got some MOU. There also we got MOU. So you can submit any design from RTL to GDS2 and with the to the foundry. Okay, so this is a design flow. So here what I am insisting, why HDL? So because of, compared to C language, because of timing we need a clock, because inside the circuit you have to say at what time what function has to be performed. Read operation, write operation, fetch, decode, fetching the instruction, decoding the instruction, executing the instruction, store the result. At what time with the clock you have to specify at what time you are going to fetch the data, at what time you are going to decode the data, at what time you are going to, okay. So it may be a parallel processing or pipelining that we'll discuss later in theory part. So for that you need timing and the parallel operation. Parallel operation can be done in the circuit. So that is technical name is concurrency. But in C language you cannot do any parallel. Only all the lines codings, thousands lines if you write the coding, okay, one by one, one by one, one by one, it will run. Sequentially it will run, which takes more time. So more time, access time, with respect to the access time, the speed will be less. So you cannot optimize your design with respect to the VLSI parameters. So you know what are the VLSI parameters? The important parameters in order to optimize your design: area, speed, power. If you go to the mobile shop, if you want to buy a mobile, so what are the specifications you prefer? Good specifications, high speed. I need high speed processor. I need less weight, less area. Power, I want low power, high speed. So these are the client's requirements. So depending upon the application, but all these area, speed, power, there is always a trade-off between these parameters. Between the parameters. So depending application, some application require low power application, some application require high speed application. Okay, some application require less area. So in order to optimize your design, okay, the HDL is used that you can design. So because of this timing concurrency, we are preferring HDL. Okay, in C language, it will run only sequentially. In sequential, in C also we have studied now that access time, how to increase the access time. Any idea about how to increase the access time in C language? In how to write the coding in C language? So normally, again here, whenever I'm while teaching, with my out of experience, some industry related questions will come into my mind. I'm transferring to you. So in normally then C, normally I used to ask the students when they are coming out after the placement. No, okay, come. What are the rounds you sit? Okay, so what is the first round, second round, third round? What are the technical questions they asked? So normally we used to make out note. Okay, ma'am, they ask the fundamentals, they ask the coding style, they ask the design flow style. So in the last year, I have attended one of the industry relevant course at Wipro. In Wipro, our SRM got a MOU with Wipro. So after some COVID batches, Corona batches and all, they found very difficult to give training for the students. They are not strong in fundamentals. So normally the company people will come for hiring their students and they will give the training for the students on first 6 months or 3 months in the company. But now they are very smart. They are giving training to the faculty. So we are attending through our department. We are attending the FDP programs, the whole semester program, 3 months program. Within 10 days, we will explore how to uh, give the training for the students. So they taught what are the trainings they will give for the students, the tool exploration and the coding exploration with the different styles. Then here, then they change the term from hiring and training to training and hiring. Concept understand? Hiring the students and the training they given. Now You train the students according to the industry requirement, and you send, then we'll hire. Training and hire, that also we are doing now. So previously we are very much loaded with the academic courses and fundamental concepts knowledge transferring. Now the next stage we moved, what is the industry requirement in order to get good placement for our students, and the SRMST should be in the number one university. We are moving our academic to industry relevant. So industry relevant courses are introduced, and we are giving training to the students. At the end of the semester, they will come and recruit the students who are all done this course, industry course, and what is their progress, the complete progress. I have to maintain an Excel data. What are the assessments I have done? How they scored in the assessment, and how they internal marks, and in final university exam, what are the grades they got. Then from that list they are selecting, and for them only they are giving placement, internship offers. So now we are in position to motivate, to coach the students from academia point of view. We have to cover all the syllabus, and we are coaching you to get into place into the industry also. So that's why I'm recording this video particularly for third year students VLSI course. Please kindly go through and explore. Okay. So now in a short time I have given the what is a HDL, what is VLSI. Billions of transistors are built in a single IC. Why VLSI? Because of CMOS technology. CMOS technology, VLSI. What is CMOS? Combination of PMOS and NMOS. Why CMOS? Because of low power, we prefer CMOS. How the low power you are getting? Because of reducing the switching activity, we are getting low power. That's why still it stands VLSI using CMOS technology. Other things, the research topics, apart from CMOS, the FinFET, lot of other research areas are going. But now industry, CMOS VLSI design, okay, using Varilla HDL, that you have to learn. Okay, now we'll come to the again the program, HDL program. In detail I'll teach you, only now small program. Assign. Next, assign carry, ASSIG, assign. C is equal to uh, A, okay, A and B, or pipelining operator. The pipelining operator, okay, pipelining operator is, where is the pipelining operator? Sorry, pipelining operator. Pipelining of A and B, B and C in, and B and C in, and C in and A. So either that is a sum is equal to A XOR B XOR C. So using primitive cells here, the primitive cells are nothing but library cells. As I said, if you want to use C language, you are inputting header file. Similarly, in a hardware, if you want to use all basic gates, AND gate, two input AND gate, two input OR gate, two input and AND gate, so multiple input AND gates, OR gates, if you want to use, all are developed already by using full custom design, IC design, and already available in the library. The users, we only call those primitive cells by using their name. Just by using their name, you can call and you can utilize wherever it is required. That is called primitive cells. So the primitive cells all are already developed. The basic gates are already developed and kept in the library. Okay, but you also, there is a facility. You also, there is a feature. You can customize your design. You can create your own design, library cells. The primitive cells, or you can say library cells. Library cells using any technology. Library cells using 180 nanometer or whatever, 90 nanometer, 45 nanometer, you can use. Okay, library cells using primitive cells. Here you also can create a user also can define the primitives, that is called UDP. Later we'll teach you. UDP means user defined primitives. User defined primitives. So you also can develop here primitives. Okay. So as in this is the body of the program using data flow modeling A XOR B XOR C. As in so C A and B or B and C in or C in and D. Okay, end with a semicolon. Either you can use this one. Okay, otherwise I'll give the double slash comments. Assign assign S is equal to, okay, you can write A XOR operator is available in Verilog HDL, that is the exponent operator. B, then you can write exponent operator C in. So either you can use this by using operator or by using primitive cells. Okay, you can write the data flow modeling by using assign statement and assign the sum and carry out to define. Otherwise, this is a body of the program using data flow modeling. The other model also the simple model I'll explain. Gate level modeling. Gate level modeling. Gate level modeling. Gate level modeling using primitive cells. Primitive cells. So that will be, for example, primitive cells XOR. What is the gates we are using in that XOR gate? XOR gate, my own XOR gate E1. Okay, if it is a um, full adder, you can specify the two input output followed by input. So for example, I'll explain the half adder circuit. Yeah, half adder circuit. This is a full adder program we are doing. Gate level modeling I'll explain. So inside the gate level, what are the how the gates are interconnected? The wire and all you have to display here. Okay, that gate level I'll teach you later. Now only data flow is sufficient. I'll explain with the data flow modeling how to simulate the program. Okay, so either you can use the primitive cells data flow modeling or you can use the operators also you can use the data flow modeling. Okay, either you can use this or that. That's all. So this is a program, body of the program, any modeling, then end model. So once if you write the coding, save, okay, file, save as, so save as, okay, .b file, save. The file name is I given FADF, save. Yes, okay. So here I got one warning dear. So expecting this line 17. Okay, here see one error warning is showing here colon, no, so semicolon will put. So save now. So once the program is written, now coding window is over. Now you see here, you select this one, then check, go to the check syntax, the synthesis part. In the synthesis part, check syntax. You do the check syntax, double click on that. So it will show any error is there. So some errors, one error is there. So you do some mistakes and rectify. So what are the errors here? So what is the line? Line 19. So 18. A, B, C in input. A, B, C in colon, semicolon. Okay. So these are all. Now I'll remove this one. Okay. Check syntax again. Say did not complete. Number of errors 1. So what is the error? Token A. So what is A here? Specify the IO ports we declared. Some A, B, C in. S and C are the outputs. A and B, C in are the inputs. Input A, B, C in. Assign S is equal to A XOR B XOR C in. And assign, so input A, B, C in. End with this semicolon. S, C. A, is equal to A. Assign yes. We'll check S. Again errors. What is the error? AB assign C, ABC, ABC. See, what is the error? We'll check ABC, A, and is colon semicolon we found. So what is it? Line 18. Line 18. Unexpected token. Compiler error. Dot B file. Unexpected token A. We got an error. So A, B, C. Okay. Already I written the coding. That I'll, okay, I'll find out what is the error. And A is there. As in A, summon C. We'll check. Same error. Same. Check syntax. Okay, let it be. I'll find out what is the error. I'll open, this is I saved. Okay. So file, I'll open the project already what I written the code. So here I can choose the combinational dot element. So here, full adder in that C. Here I developed one code half adder combinational circuit. So in that if half adder is there, I'll develop the code half adder. Okay. So I'll take this code, I'll check you. So here I written everything. Half adder I developed, half adder, sum carry AB, output SNC, input AB, assign A XOR B, and sum is A and B, and carry is A and B. Sum is A XOR B, and carry is A and B. So once you've written the code, then end model. In end model, there is no semicolon. Okay. Then once you've written a code, okay, uh, I can choose this one again. So I can run the code. See, I have checked. So I because I have done all the steps, check syntax. Okay, I'll do some mistake here. Then again we'll do. Okay, save. Once it is saved, now check syntax. See, check syntax. In the check syntax, it shows one errors. No, so it shows errors. What are the errors? So next one token be like that. So here I can correct the code semicolon into the semicolon. Then I can save. I can save. Then you do check syntax. Then succeeded. So the it will show the tick mark. Then you select RTL schematic. It is succeeded. The IO terminal list will be displayed. A and B, S and C. Then you click on that. You will get the internal components. Then you choose the coding file. Then RTL schematic is over. Then check syntax. Then implement design. You can do the implement design. Uh, and mapping and placement routing everything. So in that transit you can do. So the once the coding is correct, no, all it will be automated tools. Then mapping you can do. Then placement and routing you can do. After which, if you generate the files, okay, report files, all the files will be report files will be generated. In which what are the how many yeah, cells are occupied. Okay, so device generate placement and route, and here if you see what are the report files, how many cells are required, what is the error, what is the power, everything will be displayed. Okay, so with this I think we can complete the session. Hope that you will explore. Okay, thank you.